Hi everyone, this is Vinay Sharma, and today we are going to predict our students' examination score based on their study hours, and we will use linear regression model for this task. And I am using Python for coding. So let us see the look at our data set, and here is our data. So as I can see, there is hours and scores. There are two columns. First is of hours, which will be our input, and scores, that will be our target. Now let us see which all the libraries do we need, and here are all the libraries we need to import. And so first is NumPy, second is pandas and matplotlib and seaborn, and last one is sklearn dot linear model. So these are all the libraries we need to complete this task. After importing all the libraries, we need to import our data, and here I have imported all the data using read CSV method. And to confirm that the data has been imported or not, I use dot head method to see the first 5 rows of my data, and here we can see the first 5 rows, so we can safely say that our data has been imported successfully. So after that, I have used dot info method to check if there is any null value in my dataset, and thankfully there is no null value. And after dot info method, I use dot describe method to see the basic info about my data, that is the mean, standard deviation, and minimums, maximums, 25 percentile, 50 percentile, and 75 percentiles. So further, I have declared two variables, small x and small y, where x contains the data from R column and y contains data from score column. We know that the score is the one we have to predict, so I have used y variable to define that. And after that, I plot a scatter diagram between scores and R's to visually see if there is any relation between the scores and the study hours. And here we can clearly see that as the study hours increases, the scores also increase. Now I declared two more variables, that is capital X and capital Y, and they contain small x and small y respectively, but I have reshaped the uh, values from 1D to 2D array, as we are using sklearn and sklearn does not use 1D array, so I have to reshape the variables. After that, I split the data into two parts, that is training and testing, and I use train test split from sklearn. So that is we need to do, because first we will train our data on the basis of our data set, then we will check the our predicted values from the test data, and we will compare them with the actual values. So after splitting our data, we can run our regression on our training data, and here I have created an object of a linear regression class, that is st underscore reg, and I fit xtrain and ytrain variables into it, and our regression has been successfully completed. And as you can see now, we can get the equation of our linear model. And again, I plot a scatter diagram between x and y, and it also contains the regression line this time, and we can see the line is fitting the data set very well, and it is looking quite good. And now we can test our model using the testing data which we created using the train test split. So Here I am using dot predict method to predict scores of our test data, and I have created a pandas data frame. As you can see, df, that is the pandas data frame I have created, and it will contain our predicted values, so we can compare them with the actual values. And here we can see we are close to the actual values. And let me get to the actual table, and yeah, here here we can see we are very close to the actual values. And to evaluate our model, I have created a scatter plot between the actual values and the predicted values. And we can see that these points lie around a 45-degree line from the origin, so it means we are very close to the actual values. Now we can predict a student's score who study for 9.25 hours, and here we can see that the result we are getting is above 93. So as we saw that the increase in study hours increases the scores of a student, so we can safely say that the uh, model is getting the logic of our model. So after this we can evaluate our model using various matrices, and here I have used root mean square error and mean absolute error and r squared and adjusted r squared to evaluate my model. And here we are getting mean square error of 27 and root mean square error of 5, and mean absolute error is also around 5. So these values are low, so we can say that our model is good at predicting the values. And r squared and adjusted r square values are also above 0.95. So our model is getting the logic behind this data set. So we are we have made this model a very good fit. So if you have liked this video, if you have any suggestion, you can post them in the comments. And I hope you have liked the explanation and the process which I have walked you through. And thank you for watching.